All right. Hello, everyone. Again, now the second section of Euclidean geometry will carry on some other questions of past papers. Now, what we read in this question, it says PQRS is a parallelogram. Remember the properties of parallelogram, the opposite sides parallel, and yes, and they are equal in length, yes. So like the question says PQ is 6, so I can tell you SR is 6 as well. That's one important information. The parallelogram is very important word over there. So we can even highlight it again. And then diagonals intersect. So diagonals intersect at M. That's another property of parallelogram. So diagonals bisect each other in a parallelogram. So I can tell you PM is equal to MR. And on the other side, QM is equal to MS. So diagonals bisect each other. And accordingly, when we read, it actually tells us PR is 8. So because PR is 8, so that means what is PM and what is MR? It is 4 and 4 because diagonals bisecting in a parallelogram. And it says RU is 5, okay, VS. So it's only this part is root 13, VS. Anything else given? Oh yeah, there is a 90 degrees. Oh, because of 90 degrees, what can we say actually? We can use Pythagoras theorem. We can say PQ and PR. So QR square will be, let me write on the top because I know we'll get the answer. So we can say PR square is going to be, sorry, QR square is going to be PQ square plus PR square. So it's Pythag. So using basically Pythagoras theorem, so that can help me to find QR. So QR will be root 100, which is 10. Okay, so then I can tell you QR is 10. Because QR is 10, PS must be 10 as well, remember. Anyway, now, do we know anything about V is a T is a midpoint or anything? No. But what we know, since I got the QR is S, I can tell you PS is 10 as well. You see, QR and PS are same, so that must be 10. Now, let's read the questions. UR over RQ. So UR over RQ. So actually, UR over RQ is 5 over 10. At the moment, I know the answer anyway. So that means whatever we have done as a Pythagoras theorem here, up there is important for the first question. So I have to write this thing, and then I can get the answer. So I can get the answer as what? I can write the answer. UR is 5, it was already given, and RQ is 10, which we got here. So the answer is 1 over 2. We need to write any reason? No, not specifically, that's it. And then the second one, VM, so VM over MQ, VM over MQ. So how can I get this length of MQ? So you see, we need to use that Pythagoras theorem again. Let me just highlight how do we use those Pythagoras theorems there. Like the first one was this right angle triangle. You see, because of that's 90 degrees, so it is 6 and 8. Remember that 6 was given, and together it was 8. Now in the second condition, I will be using the interior one. So I will be using just this part. So I can get the length of QM. Okay, so what is the length of QM? So QM square this time is PQ square plus PM square. It's again using Pythag. So that's I need for this second question. You see, the previous one, it was 6 square and plus 8 square. But here, it's going to be 6 square plus 4 square. That's what? 36 and 16. So which is 52. So, and what is 52? What is root 52? So QM is root 52, which is 2 root 13. Root 13. Okay, so now I got QM is 2 root 13 after this. Now, what we know is diagonals bisect each other. That's why I can actually say MS is Q root 13 as well. Now, because Vs is already 13, so it must be root 13 and root 13. Why? Because I know Ms is equal to Mq. They both are equal to 2 root 13 because of parallelogram. The reason you can say is PQRS is a parallelogram. Okay, parallelogram. Diagonals bisect each other. Okay, you can just say diagonals in a parallelogram bisect each other. Actually, after writing this, we have the idea. What is Vm? Vm is root 13. That's it. And then what is Mq? Mq is 2 root 13. That's it. And so the answer is 1 over 2. Okay, both answers we end up 1 over 2. And then, so the last question is, we got the question says MR is, MR, where is MR? MR is parallel to VU. So how come these two lines become parallel? So what can we use as a ratio or relation? So I just want to highlight and draw that shape down here so that we can see it easier. Actually, if you just focus this part, there is a Q, V, so there is VU, okay, and there is this one, and there is MR. I just want you to focus this. Let me just draw MR a little bit more that side. So now look at the things that we know. This is Q, that is M, that is V. I want to focus on this part. That is R, that is U. Yeah, I know this is 10. I know that is 5. Let me write in a different color. So I know this is 10. I know that is 5. And I know this is root 13. And I know that is 2 root 13. This information is enough to say the lines actually parallel. It's actually only 2 marks. But what we are going to write is this, like QR over RQ is equal to QM over MV. Or the long way, you can say QR over the whole thing. You can even think about that. QR over QV, QU is equal to QM over QV. So whichever the one you write, basically we'll just write that. So, but let's write the basics, minimum thing. Let's say QR over RU is equal to QM over MV. They both equal to 2. And because of converse proportion theorem condition, we can say the lines parallel. That's all. MR is parallel to VU. It is there. The problem is you should be able to focus that correct shape. You see 10 and 5 and 2 root 13 and root 13 is there. You just need to focus whatever you need correctly. And this question, yeah, we use a bit of proportion theorem, but mostly we use this right angle triangle. You see, that right angle given was very important information. We use that Pythagoras theorem relation twice. Okay. Now, in our next question here, actually this question, as you see, there are proof questions. Question 11.1 is a proof question. So it is good to have proof questions. Just as we mentioned, there is a equiangular angle proof. They can ask just like this one here. If the angles are equal in 2 triangles, the sides are proportional with the same ratio. That's 6 or 7 marks. Here it is 7 marks. And there is proof of proportion theorem. When there's a parallel line inside a triangle, it divides the other 2 sides with the same proportion. That proof can be asked. These are grade 12 proofs. And the remaining grade 11 proofs that you must go through all of them. Tan chord theorem, opposite angles of cyclic angle at center. And angle at center can be in different shapes. You just go through all these possible proof questions, please. There's definitely one proof question coming. Now, this question now, tan 11.2, we have 2 tangents. Okay, it's good to know there are 2 tangents because you know there's a theorem with tangents. Tangents from same point are equal. I can just say PQ is equal to PR. See, because there are 2 tangents from same point. I know the reason. I can write it if I need it. And then QT is equal to QR. I mean, it's not scaled, but they tell you they are equal. So don't take a ruler and see, oh, that looks shorter, whatever. It's not the problem. It looks shorter, but the diagrams are not drawn to scale. You know that. and then Q1 is X. So that information is given. Let's just write here, it is X. Is that all we can have? These are the tangents, those two equal. Yeah, that's fine. So I can actually just zoom the question and don't worry about the rest. Okay, so that's my question. Let's go through quick. Now we need to find the three possible angles equal X with the reasons and everything. Now what can we write because of tan chord theorem, because this tangent, you know, which angle is opposite to the chord? What is my chord? Is QT. So this angle must be X as a first one. R2 is X because of tan chord theorem. So that's R2. After R2, I can say that T1 is X. Why? T1 is X because that's, you can actually say angles opposite equal chords or sides. Equal chords, or you can say equal sides because they both chords anyway. What else? Now, if we got the T1 and R2, where is the third angle? Now, you can actually think with the cyclic quadrilateral, I mean, with the tan chord theorem other way, which is Q3. You see Q3 as well. At the end of the day, it's tangent. There's a tangent and the chord. So opposite to this chord is T1. So we can even say Q3 is X as well. That's again tan chord theorem. And after Q3, can we say R1 is X? Yes, R1 is X. Like three of them is enough, but let me just write it anyway. So R1 will be X. Because of same reason, you can even use the previous reason, tan chord theorem, or you can say what? Tangents from same point. That's why that's why you get an isosceles triangle, and those are the sides opposite equal. Those are the angles opposite equal sides. So angles opposite equal tangents, you can say. Angles opposite equal tangents. Tangents from same point. Okay. Or otherwise, you can always say tan chord theorem looking at the other one. We actually find the four angles with the reasons equal to X. Okay. So that's fine. Now the question 2 says Q2 in terms of X. Q2 is, once you get the others inside, it's basically 180 minus 2x and sum of angles, I mean straight line angles, that's it. We're just gonna write 180 minus 2x, and the reason will be straight line angles or angles on a straight line, okay. And now show that the TR is, so let me write there, TR is parallel to QP. TR and QP parallel. Okay, as you see, they don't look parallel because the shape is not drawn to scale. Now, when you're looking at a parallel line condition, you just need to find out what will happen if it were parallel. You see, it's like backward thinking. If it were parallel, what could be happening there? We could have proportion theorem maybe, okay, but most of the time it is corresponding co-interior alternate angles. So basically we need to check, is there any corresponding angles equal? Is there any co-interior angles supplementary? Or is there any alternate angles equal? Fine. Which one is possible or easier to see or to show, or which one we already have? Now, looking at what we already have, let me just highlight that part. Actually, you can drop another picture and then we can have it smaller size to see what is it about. Yeah, so let's make it smaller. I just want to show that part here. What is that? It's actually this. When we have there is this angle, it's that shape. So we actually we show that angle R2 and then Q3 are equal. Okay, those angles are equal. That's why it is that shape. That's alternate angles. So alternate angles equal. Remember, alternate angles are not always equal. If the lines parallel, alternate angles are equal. And if the alternate angles are equal, then the lines parallel. So this is what we are going to say now. Alternate angles are equal. That's why the lines parallel. Otherwise, it wouldn't work. So we will, it seems it will be easier to go with alternate angles, that option. And since we already have R2 is equal to Q3, we already proved that they both equal to X. You can say alternating angles are equal. Okay, so that's why TR is parallel to QP. That wouldn't be a problem to write this now. And then showing the similar triangles. Okay, that's kind of always easy because the similarity is already given. You just need to find that order. Angle S is equal to S, T is equal to R, R is equal to Q. But to be able to write it correctly, you know what? We need to write those angles. Okay, let me solve it on that side. What are the angles in STR? Now, STR, there is S, there is T2, there is R3. And what are the angles in SRQ? There is S again, there is RQ. So there is R2 and 3. And then there is what? Q. Q is Q2. So now, when we are looking these angles, so you can just say we will be checking these angles and they must be equal in that order. Now, I just need to show two of them equal, and I'll say because of angle by AAA, they are similar. Now, the first one is kind of easy. It's S is common angle, okay? And then which other one is easier to say? Can I say T2 is R1 and 2? It doesn't look kind of easy. You see, I will leave it at the end. I can go for S and I can go for R3 and Q2. Why? Because R3 and Q2, if you look at here, it's actually tan-chord theorem. See, that's actually tan-chord theorem relation because that line is tangent as well, remember? So, so let's just write it then. You can just say S is the common angle in both triangles. And you can say R3 is equal to Q2 tan-chord theorem. And finally, the third one, T2 is equal to R2 plus 3. Why? Third angles in a triangle anyway. Third angles in triangles. So that's why, because of AAA, I can actually write the similarity. Okay, so then we'll just say by AAA, you write what they ask. That's it. Okay, we are getting through the end. Now, such questions after similarity, what we said, remember, 99%, you'll just write the ratio from the previous answer. Just write the ratios. What are the ratios, what we are talking about? You just write, like, we don't know which two is going to help, but just write first two ST over first two SR is equal to last two TR over last two RQ, and then first and last SR over first and last SQ. Now, if you look at this, which two is going to help me to get what they want? I need SR. Okay, there is SR, there is ST, so I'll take first one definitely, and I'll take the last one. Yes, obviously, when I cross multiply this, I will get what they want. You just cross multiply and get SR square is what? ST times SQ done. 2 marks. That's it. So you can easily get what they want in that case. And then the third one, the last one actually, the last here, it is further given a ratio. Now, what is that ratio? 3 to 2. So if it is given 3 to 2, what is S? Oh, we just need to show SP and PQ. So what is 3 to 2? What do we do when that ratio is given? We can't say the length is 3 and the other length is 2, but we use 3K and, for example, 2K. That's fine. And because QT is equal to QR, I can tell you this is 3K as well. Okay, so that's 3K and 3K, and it is 2K. Now, show that SP, where is my SP? SP over PQ. SP over PQ. You know what? I will use not similarity this time. I want to use the proportion theorem actually, because you know those lines doesn't look like parallel, but they are parallel. So I can actually say because it is 2 and 3, that will be 2 and 3 as well. and then those are equal. So then I will be done just like that. The only problem in this question, it's a serious problem. It is not easy to see the lines parallel. I mean, it's not easy to see proportion theorem because the lines doesn't look parallel. But since they are parallel, nothing is wrong. I can write, okay, I cannot write 2k and 3k again, but I can write like 2n and 3n, nothing is wrong. And because this is 3n, that will be 3n, they are equal. And then I got the answer because what they want is 5n over 3n. So I got what they wanted. That's it. So now, but how do we get 3 marks? If that's it, it's not just it. Sometimes we need to get it. So how can we write what we taught and how we got this? We need to write this SR over RP is equal to what? ST over TQ. And ST over TQ is given. ST over TQ is 2 over 3. Like that information is given in the question. You see, 2 and 3, that relation is given. That's why it's just 3 over 2. I wrote it upside down, doesn't matter. So this information I use there, that's given. But how can I write what I wrote? Is because of proportion theorem. Proportion theorem, why? Because TR is parallel to QP. Now, once you have written that, you can just write, you can just say, like, let what? SR is 2n, and then RP is 3n. You can just say that. And then SP is 5n. That's nothing is wrong to say that. SP is 5n. But now, how do we know QP is 3n as well? That may be the last thing we have to write. You see, I said they are equal because they are tangent from same point. So I can just write maybe a last one. So finally, QP is equal to RP, so which is equal to 3n because they are tangents from same point. So I have, that's how I got 3n. After all these, I can just get 5n over 3n. That's it. Okay. Yeah, so the problem was thinking about proportion theorem because the lines are not looking parallel anyway. All right, there's another question. As you see, circle inside a circle, which they used to ask sometimes. Let's see, that's a cyclic quadrilateral. Yes, we can see. There is tangent line, we can see. There is diameter. Oh, what is diameter? That's an important information. AD is diameter. Okay, since AD is diameter, when you read that, don't forget, just say 90 degrees. Why B2 is 90? Because AD is diameter in the big circle, isn't it? Yeah, in the larger circle. And B1 is 30, that's it. Okay, now let's focus with this information. That's 90 degrees because it is diameter. Now the question says why B2 is 90? Oh, we just said it is 90, man. Why is it 90? Because angles opposite, angle at semicircle, angle at diameter. Actually, this is kind of cheating for you. You know, the question tells you the answer. Like in case you couldn't see that or you may not sure, but it makes you sure it is 90. Just say why. And then calculate the size of F2. So then that's tan chord theorem, which is 30. We can just write 30 degrees. Don't forget the reason. Tan chord theorem, 30 and 30, because that line is tangent for both circles. Now, prove that the lines parallel, CF and DF. Actually, I can even say D1 is 30 as well, because of the same reason, tan chord theorem in the big circle. So let's write it. I can say D1 is equal to 30. Same reason, tan chord theorem, this time in the large circle, larger circle. And now, because D1 and F2 are equal, corresponding angles are equal, that makes lines parallel. So F2 is equal to D1. What do we say? Corresponding angles are equal. That's why it makes what they wanted, CF parallel to AD, converse of corresponding angles relation. And finally, angle E. So to find angle E, how does it work? Like, let's just have a small relation here. that will be 60 degrees because that's 90 and that is 30. And opposite of cyclic, that will be 120. See, opposite of a cyclic quadrilateral, that you can write the reason. So let me just put a smiley face. You will write what we said. Okay, this diagram looks a little bit more complicated. There is a center. H is center, very good information. Remember, when center is given, you must be careful. There may be a diameter, there may be angle at center, line from center, or isosceles triangles. There are a lot of possible things when there is center. So that's why it's very critical information if the question tells us there is center. Now, find 5 other angles equal to x, or 3 other angles equal to x. Now, in the big circle, you can see the same segment angles, isn't it? Like it looks through HP. So opposite to HP is actually this here. See that S3. S3 is same as F1 because they both look the same part of the circle in the big circle. So that's my first one. I can go for S3 and then say same segment angles. Same segment angles. After S3, what can we say? That's the first one. Now, after S3, see, I want to use that circle relation, and I can tell you these two are equal. And that's why I can tell you now P2 is X. It's an isosceles triangle. So why P2 is equal to X as well? Angles opposite equal radii. Angles of, so that's my P2. So after P2, actually now I can have F2 as well. Actually for F2, I may have 2 possible reasons. Remember that reason? Angles opposite equal chords. Because HS is a chord and HP is a chord. And those are equal. HS and HP are equal. Because they are radius for the smaller circle. So I can tell you F2 is equal to F1 because these are the angles opposite equal chords. Or after P2, I can just say same segment angles. So both reasons are acceptable anyway. So F2 is my third one. You can have 2 possible reasons. You can say angles opposite equal chords. That's my one reason. Or you can say same segment angles, thinking P2. Okay, remember first one, S3, we thought about F1, and then to get F2, we thought about P2. Okay, same segment angles. So that's, we got 3 possible other angles equal to X. Can we have more? Maybe not. They ask 3 anyway. So that's 1, 2, 3. Now, express SHP. So SHP is this angle. Actually, it's angle at center. So we already know X and X. So that answer will be 180 minus X. So sum of angles 180 minus 2X. The reason will be sum of angles in triangle. And R, so that's angle at circumference, half of it. So basically half of 90 minus 2X, half of 180 minus 2X is 90 minus X. The reason is angle at center is 2 times angle at circumference. Okay, so far so good. Then prove that SF is equal to TF. Now, SF here is equal to TF. So for us to those 2 sides to be equal, what we must have, looking at a triangle condition, we must have base angles equal. So we must have S1 is equal to T1. How come they are equal? What are their values anyway? So let's find them. We can, okay, we already got the R. So we know R was 90 minus X. Now, looking at the cyclic quadrilateral, T1 is same as R. So that's exterior angle of cyclic. So then I can tell you this is 90 minus X. So since these are X and these are X, it actually helps a lot. I can tell you that if this is 90 minus X, this is X, the angle at L must be 90. So that must be 90. So that must be 90 minus X. You see, I actually already got, it's an isosceles triangle. But the starting point and that important part is what? Thinking about T1 is A at 90 minus X, T1 is R. So from then, it's kind of easier. You just say T1 is 90 minus X, which is R, because what? Exterior angle of cyclic. So after T1, you can actually find S1 straight. Why? Because look at angle F. It is X plus X, 2X. So what is S1? Don't worry about finding those 90s and everything. I can just write the answer. What is S1? It's sum of angles in a triangle. 180 minus what? 180 minus 90 minus X plus 2X. See, those are the other angles in triangle. So that I can say sum of angles in a triangle. Which triangle we are talking? TSR. TSR. So we have two angles we are talking. Angle TSR. Okay. Sorry, TSF, not R. TSF. I thought it's TSF. So this gives me what? 90 minus X. So since I get 90 minus X and 90 minus X, so I can tell you those sides equal. So what will be the reason to say those sides equal now? Because these are the sides opposite equal angles. Okay, that's what we should write. Sides opposite equal angles. That will be the reason. All right. So this was another question which has two circles inside. If we move on, you see that's the proportion theorem proof that we were talking. When the lines parallel, you need to show that the other two, the parallel lines divide the two sides of triangle with the same proportion, that relation. And just below it, there's a question using this proportion theorem. Let's have a look together. Now in the diagram, those lines parallel. So whenever ratios are given, remember what we do. We don't write 2 and 3, but we write with x and or k's or no, with different variables. So AP and PE. That's why I can write like 2x and 3x, AP and PE. And now this is, let's say this is our pencil work. I can say AP over PE, which is same as AB over BQ. Now, because it is 2 to 3, I'm not going to write again 2x and 3x, but I can write 2k and 3k. Now, that's just using the parallel line with the PQ. See, now, using the big parallel line, can I write like AQ and QF with the same ratio? Look at here, using those parallel lines. Yes, of course, I can do that. Now, again, I won't write 2x, 3x, or 2k, 3k. I have to use another variable because they have the same ratio, but they don't have the same length. Okay, so let's make it maybe shorter. Those ones, the yellow ones, just to see that green condition. So what am I going to write? Maybe this time I can write 2n and then 3n. Okay, so I can just write these with the ratio of proportion theorem and the parallel lines. But now it's our pencil work. No. Now what is given? What else given? It says AE is 120. There is AE, yeah. So if AE is 120, so then this whole thing is 120. I can get the individual values. And QF is 60. So that is like 60. So those lengths are given. Using QF, I can find the value of n. And I can find the value of AQ then. So I can find other lengths just like that. So from then, everything else becomes very easier. And if it were a multiple choice question, I already got maybe all the answers just like that. But because it's not a multiple choice question, you just need to be careful writing the reasons in correct order again. Let's do that. Let's do that. Calculate the length of AP. Now, okay, what do we say with that given information as a minimum requirements to be written? I can say let AP is equal to 2x and PE is equal to 3x. So because that's given 2 over 3. So then what can we say? So we can say 5x is equal to 120 because 120 is given. I already wrote that. So what is the value of x? 120 over 5 is 24. So if x is 24, what is AP? 2 times 24. 2 times 24 will give me 48. That's the length of AP. AP is going to be 48 meters. Do I need any reason, anything? Nothing. We didn't even use proportion theorem at all. Now, and then the next question asks AQ. Remember, we are given QF. Now, this time, to be able to get that ratio, I have to write proportion theorem. Now, how do we write proportion theorem? I can say AQ over QF is equal to what? AP over PE. Remember, AP over PE is given 2 over 3. And why do we write, or how do we write this ratio? Because there is proportion theorem and because PQ is parallel to EF. Okay, you shouldn't write the other parallel lines. So just like what we did in our pencil work, we said, so let's say AQ is 2n and what? QF is 3n. So just like we wrote up there, same thing. So I know QF is 3n and it is given as 60. So I can tell you n is 20. So if n is 20, you can tell me what AQ is. AQ will be 2 times 20. So AQ is 40 meters. That's it. 4 marks. And then the last one, AB over BQ. Okay, we already said that 2 over 3 with a pair. Okay, I'll just smile it. Don't forget the reason. Okay, so this is how you solve questions with the proportion theorem. Be careful, you can use your pencil work before starting the question. Remember writing the parallel lines as the reason. And don't write 2 and 3. You can write 2x, 3x, and because of that 2 and 3, this is 2k, 3k, or again, this is 2 and 3 and whatever. And one more thing before moving on, in case we won't see any question like that. Whenever the parallel lines ratio asks, then we better use the similarity. Similarity, the triangles, parallel lines makes triangles similar, That's why there's a ratio of similarity. So ratio of similarity is the ratio of parallel lines. Like if we ask PB over EQ, that's the ratio of parallel lines, which is 2 over 5. That's the ratio of triangles, 2 over 5. Or similarly, if we ask what is PQ divided by EF, that's the ratio of parallel lines, which will be the ratio of triangles. So what is PQ over EF? It is again 2 over 5. Okay, just be careful with that. All right. Now another question. So remember, in finding the possible similar triangles when there are circles, we had a few conditions. A few famous shapes, and this is actually one of them. I can just quickly remind you, like when there's a circle and triangles inside, or when there's a circle or a tangent line or a cyclic quadrilateral. So what kind of situation? Like the first one, let's say the first one is like this question. There's like that butterfly shape inside the triangle. Somehow you got that. So this gives us 2 similar triangles always. Or when you have something like that. So again, this gives us 2 similar triangles always. And when there's a tangent line, what happens when there's a tangent line? Something like that. So this gives us always 2 similar triangles. Why? Obviously, because like this angle is equal to that one, and those angles are equal to that one here. And in this case, this angle will be equal to here because exterior angle of cyclic, and that angle will be equal to here, the exterior, and there is what? There's common angle here. Same as when there's a tangent line, there's a common angle. Remember tan chord theorem, this angle here is equal to that angle over there because of tan chord theorem. And the third angles will be equal. So these are kind of famous shapes that you can always get similar triangles when there's a circle and different triangles in the diagram. So this one here that we have is actually just like that first one, like we mentioned before. You have possible similarities, and this is the first one. Look at that. But look, the question is not asking similarity, but it's 5 marks. That means you need to show a kind of a similarity and then maybe the ratio of similarity and so on. Now, let's see, there is AE, the whole thing, and there is DE, and there is BE square. Is there any diameter, any center, anything? No. Okay. And those angles given equal, okay, let's use that. So that's A1 is equal to A2, that's given. And A2 is equal to B1 because of same segment angles. Okay. So that makes us two angles equal. Now, this question then is becomes a little bit different. Why? Because if you just highlight what we need to write, there is AE. Okay, where is AE? I'll just highlight it. AE is all the way from A to E, and then there is DE. So it's this part, and then there is what? There is BE, and we have like twice BE squared. So that's why I have to focus the triangles on this side here. I must have triangle ABE. I must have a relation between triangle ABE and BDE. So because I have the sides of these two triangles. So now how can I say a relation between these two triangles? They must have kind of a similarity. And when we write the ratio of similarity and cross multiply, then I'll get this thing. So it's not one of our famous shapes then, it's a little bit different now. And there's an extra information given anyway. So I will be using that extra information. So looking at these two triangles, can I say angle E is the common angle in both? Yes. Okay, let's say you don't know which order you will be writing. Remember, if the question asks prove a similarity, you already know which angles are equal. So this is a bit more difficult because we don't have any order. We have to make our own order. So to be able to have our own order, write the angles in ABE and the angles in BDE, and then figure out which one could be equal. What are the angles in ABE? Let me write in a different order, like there is A1, and then there is E, ABE. Okay, I'm just writing in different order. So there is E, and then what else we have? There is B. So that's B1 plus B2. Okay. You can write in any order. These are the angles in ABE. What about BDE? Okay, there is B1, and there is, okay, let's say D1, D2. There is D2, and then there is E. Now, I just need to show two of these angles are equal. Now, E is the common angle, don't worry about it. And A is equal to A1 is B1. Because what we said, A2 is B2, remember? So the third angles are the third angles. B1 2 is equal to B2. I don't need to worry about that. I will just write first those red lines, like E is the common angle and A1 is B1, and the others are third angles. Then I'll write the similarity, I'll write the ratio, I'll get what I need. So let's do that. First of all, obviously, I have to say B1 is equal to A2. Why? Because same segment angles. And then, so I can tell you A1 is equal to B1. That's my first thing. And then I can say E is the common angle. And then the third angles, what is that? B1 plus 2 is equal to D2. The reason, remember, third angles of triangles. Now, then we can just say, so by angle, what can we write? Write the ratio. AEB, triangle AEB, is similar to the other triangle AED. Yes, AED. And finally, triangle AEB is not okay. Is similar to BED. Sorry, triangle AEB is BED. That's right, BED. Now, how do we write that? With this order, you see AEB is here and BED is there. We are using that order here. And then always what we do, first two, I don't know which two I'm going to write, but I'll write the three ratios. First two is AB over BE is equal to, last two is AEB over ED is equal to first and last AB over BD. So which would give me what I need for this question? I need BE square. It's obviously, you can see now, it's the last two. When you cross multiply, you get what is asked in the question. Okay, so basically, so the beginning part is kind of thinking, thinking about what angles could be equal, how can we write the similarity. So we can just say it's our thinking and then we write what is necessary to show this, to solve this question. All right, and then the last one here, there is AE over DE, and so AE over DE, okay, again, the same thing, but this time it is AB square over BD square. Now, what could be the ratios again? Do we have any possible cases, like if you divide both sides with DE square, we get something. So I want to use the previous information. That's why I'm thinking that way. 99% you do that. Okay, let's look at that way. What am I going to do to be able to use the previous step? Remember, there is this left side is AE times DE, but that left side is AE over DE. You know what I will do to get the one on the left? I divide both sides by DE square. So AE times DE over DE square is equal to what? BE square over DE square. So this way I end up, actually I got at least the one on the left. So now what is BE square over DE square? So that must be equal to AB square over BD square. You know, now that's my job to show that. So how come there's this relation? How come we have a relation between what? Let's just check. BE over DE and then AB over BD. Is there any relation with that? BE over ED, AB over BD. Yes, actually we already wrote that in the previous step. You see, look at that last two now. What is a BE over BE square over ED square? If you square both sides, what do you get? You get AB square over BD square. So that's why, you see, because this thing is actually equal to, let me write in this way, maybe that could help better. The square of this can be written as this way, BE over DE square. Now I already know it is the square of AB over BD because of the previous thing. And now let's open the brackets and got what they want. I can actually write AE over DE is equal to square of AB over square of BD. That's done. Okay, it's just to see that connection and write this, the situation what is required to be written there. Okay, we didn't write any new similarity or any proportion theorem. Anyway, we just use the same proportion theorem, the same ratio with a little bit different ideas. And obviously, and of course, there could be some different ways, some other different ways, which you may find easier. But yeah, this is how we approach and how we solve such questions. All right. Other than that, all is fine. I think we can say that should be fine for now. And again, if you have any questions, we can send through WhatsApp, or we can solve together at Zoom. And please go through these questions, understand the approaching when you see the question, understand the reasons that you can write, or finding equal angles, or finding the relations using the properties and the theorems. Please, it just requires a bit more practice, and sometimes I understand it's difficult to see, but hopefully with more practice you will be getting there. All the best. Good luck.